Alrighty, so what I was hoping is that some of you would come with some questions. If not, I do have a couple of problems I would go over. But it's up to you guys. Does anybody have any questions they want to look at, or do you just want to start seeing some stuff?
No one here.
Nobody?
I thought it was late. I'm trying to be on time. It's 7.
Well, I mean, it don't matter. I'm here for you. It's not like this is class. This is if you felt the urge and felt you needed some extra practice, now would be a great time. Let me see that, Brian. Let me see that. Your card. Yeah, that's good. Yeah, that's what I'm talking about. So what do you want to see?
The pH of a buffer.
Oh, nice. Alrighty. So given a buffer with a Ka equal to 3.4 times 10 to the negative 7th and let's go in HF concentration equal to, I don't know, 4.4 times 10 to the negative 4 and a NaF concentration equal to 3.7 times 10 to the negative 5, find the pH. Okay? Now, oh, sorry. Ooh, yeah, that sucks. Right now, again, you should have the formula, right? Formula I'm hoping is on your 3x5. Everybody got this formula on their 3x5?
Yeah.
Okay. So, reminder that this value right here is what? Ka, not pKa. So first thing I need to do is I got to find my pKa. Find my pKa, I do what? So I'm going to take the negative log of the Ka, which is going to give me the negative log of 3.4 times 10 to the negative 7th, which is going to give me a pKa equal to 6 something? 6.5, right? Then I go back and I got to remember my pH equation. What's my pH equation? It's my pKa plus the log of A negative over HA, right? Now in this situation, I didn't give you these written just like this, did I?
No.
But you got to be able to figure out which one is which, right? So I know that I'm going to have my 6.5 plus the log. Now, what's going to go in the numerator? What's going to go in the denominator? NaF goes in my numerator, so I'm going to go 3.7 times 10 to the negative 5th. Then the HF goes in my denominator. Anybody agree with Heslop? Did you notice that?
What?
Yeah, I didn't call you Higley.
I know.
Yeah.
It's funny. It's
Thought
okay.
really hard
I laugh
about
every
that.
time, so it's
I
fine.
don't. So does everybody see where she got those two or why she put those two values where? I mean, this one had to go in the denominator, right? So it's the one that's got the H with it, correct? And you got me an answer, Brian?
No.
No?
Almost.
Almost?
I got 5.4.
You got 5.4 for an answer? Anybody else get 5.4? Now, Matt, what did I tell you to do when you got this answer? Who can remember what I said it should be?
Close to the pKa.
Yeah, it should be close to my pKa, is it?
Yeah.
Yeah, it's within about 1. That's what's going to happen. Okay? And there's, I think, 1 or 2 of those on the test, just like that. Okay? Anybody else?
Yeah, that's right.
No, I mean, does anybody else got a question?
Oh.
No? Okay, so here is a good question. And this is kind of a cross between what you'll see on the homework or what you saw in the homework and what you did in class, because there was a couple of problems where they kind of intermingled the M1V1s, if you notice what I mean, right? It's like I said, given a H2SO4 solution, okay, with a molarity of, I don't know, let's say I got 0.27 molar, right? And a NaOH solution of 0.15 molar. Okay. If you need 23.4 milliliters of H2SO4, how much NaOH did you have, or something? Okay. And it's kind of wordy, but it gets my point across. And that is, I know no matter what, this is going to be an M1V1 equals M2V2 of sorts, right? But I got to go back and figure out what numbers go where and where my what goes. There's going to be something in this that's different. My 2, right? I got to have a 2. Why do I have to have a 2? The acid is diprotic. That's like spoken like a chemist there, Brian. Good job, right? Now, so I'm talking about my H2SO4. So what I got thinking about, and part of that was because I had this question last night from a student. I would literally say, let's look at this and let's just pretend that my acid is on the left and my base is on the right. Okay? So what numbers are going to go with my acid? Okay? Well, it says, given H2SO4 solution with a molarity of this, I know that that's got to be 0.27 molar, right? Okay. And what else is going to go right here?
23.
Yeah, I've got 23, and then that's going to be 23.4 milliliters, right? Now, what else has to go on this side? Yeah, I've got to have my 2 over there, right? And then that's going to equal what's going to go over here? 0.15 molar and, yeah, V2, right? Once I've got that, the mass should be nobody? Easy, because I have a calculator, right? So all I'm going to do is divide by 0.15 molar, right? 0.15 molar divide by 0.15 molar, right? They're gone. V2 is going to be 84. 84 mils. Peyton? Drake? Okay. Just like that. And already more than I had on Friday. I think I had 4 show up on Friday, so.
I can do mornings better.
What?
I said mornings are easier.
Oh, mornings are good. You two got something specific you want to look at, or?
Well, I want to talk about like KWKA and like PKA.
Man, you should have been like, I don't know, 3 minutes earlier. Look what we did right there. Booyah. So, I mean, what you got to understand is that everything has its own place, right? KW, remember, is H3O positive times OH negative, right? Okay? But really, it equals, and that's what you got to have. You got to know that those two things, if I multiply them together, has to equal what? What do those two things equal? 1.0 times 10 to the negative 14th. And that's important because they're going to give me both of these. There are 4 ways 4 main ways they're going to ask these questions. Straight up. The hardest kind is they're going to do this. They're going to say given an OH negative concentration equal to 2.7 times 10 to the negative ninth. They will then say find the pH. This is what's going to happen. Everybody's going to take the negative log of that, and they're going to get it what? Wrong. Because this is OH, this is pH, they're not the same thing, right? Now, can I use that to get my answer? Yeah. But what am I going to find if I negative log this? I'm going to find POH. So my POH is the negative log of 2.7 times 10 to the negative ninth, right? Well, that's going to give me a POH equal to 8 point something, right?
Yep. 8.6.
8.6, right? But if I want pH, I'm going to do what?
Subtract.
Yeah, I know that my pH is equal to 14 minus my POH, which is going to give me 14 minus 8.6, which is 5.4. I'm telling you, there's like 7 of them.
Great.
And, you know, for the most part, we did pretty good. But, you know, I could tell kids started, oh, I know how to do these, and just didn't pay attention to what was given. Okay? You got to make sure you know this. pKa plus the log of A negative over HA. I mean, that's, you know, if you know that, plug it in and do the math. Remember that pKa is the negative log of Ka. As long as I know these two things, you know, it's plugging into my calculator. Hopefully I've been doing it all along. Okay.
Top one is the base, bottom one is an acid, right?
Yep, top one is my base, bottom one. And I'm going to know that, depending on how they give it to me, by whichever one starts with a what? Starts with an H. Okay? Now, the only exception to that is this. NH3. NH3 is like water, meaning it can be what? Yeah, but what's that called? Amphoteric, right? Okay, and so, for example, if I take NH3 and I want it to be a base, okay, what would its conjugate acid be? You get my conjugate acid, I do what? Do I add an H or subtract an H? I add an H. So if I take NH3 and I add an H, I'm going to get NH4 positive, right? But if I take NH3 and I want it to be my acid, now its conjugate base is going to be what? Now it's going to be my NH2 negative. So water and ammonia are probably the two most common amphoteric substances we know of. Okay? Now, probably, you know, one of the things that just has screwed people up is this. So given let's say given Na2CO3, right? In solution, it will be acidic or basic. Okay, this is probably the one thing that kids are screwing up. Okay, now look, what's already in my water besides water? What's floating around in there besides water? Yeah, I've got some OH negatives, and I've got some H positives, right? Okay, what am I going to put in there when I dissolve this salt in there? What is this going to give me when I dissolve it in water? I'm going to actually get 2 Na positives, right? 2 Na positives and 1 CO3, 2 negative, correct? Now, what are my potential outcomes here?
The H bar
Okay, so that would give me, to make that neutral, I'd have to go what? To make this a neutral compound, I would actually need H2CO3, or I would get, what's the other one? NaOH, right? Now, then I look at these and I figure out which one of these do I really get? Am I going to get NaOH? No, this will not form. And it will not form because it's a strong acid. Or sorry, strong base. Now, H2CO3, is it a strong acid? It's not, which means some of that will actually get together now. So if this gets together, what's that going to do to my H positives that's in my solution? It's going to bond them up, right? Which means that the concentration of H positive is going to go where? Down. That means the number of OH negatives in there is going to now be higher. Well, if my OH negative is higher than my H positive, that's going to make this sucker basic. Okay? It's going to make it basic. Now, the other thing that I'm going to be honest, I really thought my first period did okay on it. Not my first, my sixth did okay on it, but my seventh did even better. And that was how a buffer works against an acid or a base, right? So listen, when I have my buffer, and we always use, H, acetic acid, right? And remember that HC2H3O2 is the same as CH3COOH. This is called Chaku. Okay, these are the same thing, just written differently. I think I wrote it back there on the board. You'll see it. Okay, but understand this is in this beaker. Okay, I'm gonna have H positives. I'm gonna have a whole bunch of this C2H3O2 negative, C3H3O2 negative. And then I'll have some sodium in there as well, but the sodium doesn't matter, right? So when I add an acid, when you add an acid to this, okay, what I'm really worried about is I'm adding that H positives, right? Which one of these things is going to buffer against the H positive? The what? The conjugate base, right? So all I need to understand is this, is that the conjugate base buffers against added acid, okay? Which then by default means that what?
The weak acid's gonna
Yeah, the weak acid buffers against conjugate base. That's how that works. Because what ends up happening is, remember, this is a weak acid, so we would still have some of that together in there, right? Some of that would stay together. Well, when I add a base in here, when I add a base, right, this H says to itself, I can be bonded to this ion, or I could go bond to an OH. Well, OH is way better to be bonded with. So it'll literally break away and go and bond with that. So you'd end up having a whole bunch of the acetate ions left over. But you need to know this. Conjugate base buffers against added acid. The weak acid buffers against... That's not supposed to say conjugate base. What's that supposed to say? Weak acid buffers against added base. I don't know why I wrote conjugate base there. Buffers against added base. That is the hard questions. Yeah, questions. Test average is up 8% over the last test.
Good.
It's amazing what some students will do when they realize their grade's on the line. What's the matter?
Oh, I had a meeting this morning, and so it was either come here or go to that. So I didn't want to go to my meeting.
What was it for?
NHS.
Oh, sorry. Right, this wasn't required.
I
I
know.
thought I'd get more than this, though. And I've been here since like 6:05. But whatever.
I just didn't want to go to my meeting.
Teenagers. Oh, now we get people showing up. Better late than never, though, right? Hey, a minute. Did my email make sense?
Yeah.
Okay. Yeah, all you gotta do is make sure you put that 2 on the side that's di whatever. Diprotic or dibasic. Then it worked out. So if you do the guided practice, it takes you through this whole long, drawn out, unnecessary way to do it. You know what I'm talking about?
Yeah.
Yeah, it's just way easier to just look at it and do it. And you can actually do that with even triprotic, it doesn't matter. You know, but that works. Okay. Oh, I do have one. What happens if they give you a whole thing and then they ask you this? What is the net ionic equation? And this is no, what is this?
Oh,
Aqueous, liquid. They use the term net ionic equation. That is the answer. Every time. Do we all understand that? Every time. Okay? Oh, what about some conjugate acid-base pairs? We did one, but that was just so I could show you there was another thing that was amphoteric. So if I gave you like H2SO4, this is my acid, and I want its conjugate base, what are you going to tell me it is? Say it again. HSO4 negative. And what you learn is that pretty much every conjugate base is a what? No, every conjugate base is a negative ion. Almost every time. You know, if I gave you, HF, okay, so here's my acid, right? What is its conjugate base? Yeah, it's just going to be F negative, right? Which then makes it easy if I wanted to go buffer situation. And I said HF, and I wanted to make this a buffer. What would this be? What? NAF. Would NAF work? Yeah. Really, this Na could be anything in group 1. It could be LIF or KF or RBF or whatever. You know what I'm saying? As long as this must be a what? To be a buffer, what does my first thing have to be? But it has to be a... Yeah, it must be a weak acid. And so, like, especially on this one, it gives you, there's going to be 4 or 5 things to choose from, right? Well, I would literally go process of elimination if I wasn't 100% sure. Some of those acids are going to be strong. Well, if it's a strong, does it matter what's on the right side? Doesn't matter. Just get rid of it. And that's going to be, you know what I mean? Then whittle your way down. And then one of the ones is something like this. Like they did like like this. Like they did H2CO3 and CO3 2 negative. Okay, is this a buffer?
No,
Why not?
there's not a salt.
Exactly, and that's the thing. This is not a salt. This could be conjugates maybe. Really even couldn't be, because this is di. To be true conjugate, this would have to have at least what? 1H, right? But this is not a salt, so it can't be a buffer solution. Even though that's a weak acid, that is not a salt, so this is a hard no. Good job, Brian. Okay, make sure you remember what HNO2 is. I'm pretty sure I covered this on the review, right? Remember what HNO2 is? Say it louder. Nitrous acid. Nitrous acid. Okay. Let's see. So let's do this. Let's say I gave you
Wait, Denton, I have a question.
yeah.
So, if it's covalent, it's not going to.
Yeah. Yeah, in that situation, it's like, I know that on one of the homeworks it gave you like CH4 or something.
It gave me CHOOH. So something like that. It was like.
Chaku?
Two.
Yeah, Chaku. Turn around. Yeah. If it's got an H on it, it's like, what you got to understand is if they give you CH3, COOH, this is called Chaku. And it is the exact same thing as HC2H3O2. These are both acetic acid, which is the most common weak acid we know. It's just written differently and it makes it looks like it's something else. That's why I wrote it on the backboard. Oh, yeah, no. So like this, you want to neutralize this? You want to neutralize this?
Well, I was just asking if it was because it was.
Yeah, no. It still works. It's just these have different applications for where you're going to see them. Okay, typically they don't write it like this in the acid-base section because acids start with an H, right? And they write it like this, and all of a sudden kids go, well, it doesn't start with an H, it's not an acid, right? So it screws them up. Well, you got to understand that that H is really that H. So when I break that off, this would become CH3CO negative, and then that H. That'd be it. So like if I had this CH3COH, its conjugate base would be CH3COO negative. But there's like one question that they use that on in the test. That's why I wrote that on the backboard. Okay. Let's say, how'd it go? Was it? How's the recovery going?
It sucks.
Yeah, I'm sure it does. Why are you here? Oh, good job. Okay. Most kids would use it as an excuse to keep their ass at home, right? I mean, let's be honest. Am I wrong? No, I'm not wrong. I've been doing this 23 years. I know what I'm talking about. So good job, Tamir. Alrighty, so let's do, what do we want to see? Should we do another salt that forms an acid or a base in water? Or an M1V1? Or what do we want to see?
Let's do another salt water.
Salt water 1? Alrighty, so let's say I gave you let's say I gave you here we go. Let's say I gave you HBRO. Okay, so let's say or not H, NaBRO. What's up?
Matthew, I just wanted to give these to you.
Oh, thank you. Appreciate that.
Sorry for interrupting.
Oh no, you're fine. Say he'd be in here, but he already took the test. So you got NaBRO, right? I'm gonna put this in water. Okay. So again, what is that gonna give me?
positive.
I'm gonna get Na positive and BRO negative, right? It's called bromide or something. BRO, I know what's on here. Hypobromite. Okay. So, what are my only two outcomes here? I'm going to get NaOH or I'm going to get HBRO. So I'm going to take these two things and I'm going to look at my what? I'm going to look at my strong acid, strong base chart, right? What do I notice about this? It's a strong base, which tells me that it will not get together. This, though, is it a strong acid? No. So that tells me it will get together. So no matter what happens, the number of H positives floating around in my solution is going to go where? Down. Because it's being trapped by that BRO negative, right? Well, if the number of H positives goes down, that means that my number of OH negatives must be now higher. Well, if my OH negatives are higher than my H positives, that sucker has to be a base. Now, what if I asked you for the pH? Could you give me an exact pH? No, but you would know what? Yeah, that the pH must be greater than 7, something like that. By nature, the fact that it being basic has to have a pH. You know, see how they might ask that a little differently? So you got to be kind of careful there. Okay. Let's do this one. Let's do a titration. So let's say given calcium hydroxide of 0.45 molar. How much would be needed to neutralize 27.6 milliliters of 4.4 molar HCl. Okay. So I really liked how we did it this morning. I'm just going to write acid on one side, base on the other, right? So what do I know for my acid? Well, I know that my acid is 4.4 molar, right? And it has a volume of 27.6 milliliters, don't I? So I know I've got 4.4 molar. I've got 27.6 milliliters. Do I need a 2 over there? No, the 2 goes where? Goes on the base side, right? Because that's this, right? So that's going to equal how much? So I'm looking for a volume, right? So I've got 0.45 molar times V2 times 2. So I'm going to divide by 0.45 molar and 2, divide by 0.45 molar and 2, and that is going to give me a V2 equal to that times that. Use parentheses down there. What do I get? Yeah, I'm looking at you.
Yeah,
What?
130.
130 milliliters? Anybody else get 130? Yeah? Right there. And there's, 3 or 4 of them on the test in some way, shape, or form. Okay? Let's do one more of these. So find the pH of a solution that has a Ka equal to 4.4 times 10 to the negative third, a negative equal to 2.7 times 10 to the negative fifth, and a HA equal to 6.8 times 10 to the negative fourth. Give me a pH. Brian, you got me an answer? What'd you get?
I got 2.4.
2.4? Anybody else get 2.4? Now is that just your pKa or is that your answer?
I'll tell you off my answer.
I'll bet that's just your pKa.
PKA.
pKa?
2.4. You do the negative log of Ka, right?
Yeah. That's my pK, but then I got to add to that.
Yeah, 2.7 times 7 negative fifth divided by 6.8.
Yeah. Check your math. So I know it's going to be between about 1 and 4, right? Doesn't that make sense? Remember we said it'd be close, right? Somebody got me an answer?
3.3.
3.3? Yeah?
Oh, I didn't do the log.
Ah, yeah.
Okay.
Okay, I was like, man. Anybody get this? Nobody got 3.3? No? What'd you get? 3.4? Should Mr. Denton do this? So we're going to take the negative log of 4.4 second E negative 3, enter, plus the log of 2.7 second E negative 5, divide 6.8 second E negative 4, close my parentheses, enter. Well, that ain't right. I got 0.95.
That's what I keep getting.
Did you add 2.4?
Yeah,
Yeah, like everyone's spitting out 3s and 4s. I'm like,
this is what I got.
oh, I feel like this is hard now.
Yeah, because here's the 2.4. There's your 2.4, or Brian. That worked. But then I got 0.9. Well, actually, it'd be 0.96, wouldn't it? 0.96.
We got it.
See you guys. Oh, I can't. Messed it. We had a great discussion.